Okay, Unit 8, Lesson 7, we're graphing functions. So it's taking the last two lessons and applying the concepts that we learned in them, both how to solve a function table and then how to plot coordinate pairs. So SAB page 365 through 367. Okay, so the first thing you'll notice on here, we have some function tables, and we're just going to fill in these function tables, and then we're going to turn around and graph them. So the concept here is that Mindy and her friends are walking for charity, and they're going to earn the same amount of dollars for each mile they walk, and they want to know how much money they're going to earn for their respective charity. So on this particular one, the rule is D and M are equal to one another, so you can just kind of run through, and whatever's on the one side fills in onto the other side. So hopefully that kind of makes sense because they're equal to one another. This one is multiplying by 2, so it's a multiple of 2, so it's just doubling the number that's over there. Okay, so hopefully you guys are fairly proficient at doubling numbers. Okay, so we're going to fill that in. Okay, and the next one is multiplying again by 3. So D is equal to 3 times M. So we're going to go through and fill in with multiplying by 3, which is the multiples of 3. Okay, so got that filled in. That is a 15. I know, a very ugly one. Okay, and then the next one is multiple of 5. So D equals 5M. So multiplying by 5 again. 0 times 5, 0. 5, 10, 15, 20, and 25. Okay, so once that's filled in, this is actually what we're going to plot. We're going to take that information and we're going to put it onto a coordinate graph. Okay, we're going to connect the points with and use a ruler or a straight edge of some sort to graph their increments. Okay, so if we were going to do this, let's get a straight edge here. And I'm going to try and graph them each in a separate color. Notice that my first ones all start at 0, 0. And this one, this first graph, it goes up to 5, 5. So I'm going to start from 0, 0, and I'm going to end on 5, 5. And it goes up incrementally, 1 by 1. Okay. So 1 by 1, 1 by 1. Okay. So right, 0, 0, 1, 1, 2, 2, 3, 3, right? Those are the ordered pairs for that particular one. Okay, so the next one, when you look at it, it goes up increments of 2, right? 0, 0, 1, 2, all the way up to 5, 10. So 0, 0, 1, 2, 2, 4, right? 3, 6, and all the way up till I get to 5, 10. Okay, if you get your start point and your end point, then you can just draw your lines and connect those up. That kind of makes sense. So you're going to find your start and your end point. Let me just tell you how that works on this next one. So this next one is 0, 0, and then it goes up to 5, 15. So if I were to plot my points and start at 0, 0, right? And then I'm going to go up to 5, 15. So 5, 15 is right there. And because I'm using a straight edge, my graph will turn out perfectly. Okay, and though I should have each of my incremental points on there. And so as I go to read the graph, I should have 1 and 3, right? 2 and 6, and so you'll notice that those go through those correct ordered pairs. Let's try that again on this next one. 0, 0, and 5, 25. Okay, is where I need to end up. Let me switch colors again. So I'm going to start with 0, 0, and I need to end up at 5, 25, which is way up here. Okay, and I'm going to connect those up. So again, if I'm doing my ordered pairs very carefully, then that line this green line that I drew, should run through all of the correct ordered pairs, increments of 5. So you just have to watch those and be careful. Okay, so give 2 coordinate pairs that you could use to graph D equals 4m. Well, you would start, hopefully, with the 0, 0, right? Like I just said. Start with 0, 0. And then if we were going to go up to that 5th one, right, 5, so you're going to have 5, and then 5 times 4, which is 20. And then that would be that graph. Okay? So then if we were going to actually graph that out, all right, we would go from 0, 0 to 5, 20. And that would be my line. Okay? So what's the relationship you see in this? Hopefully you're seeing that if I know my beginning point and my end point, all the plots in between are connected up and will fall onto the line that we plot. Okay, let's try some more. These are functions, additive relations, at the age of a sister and a brother. So S is for sister and B is for brother. And what we're going to look at what happens to their age. So if their ages are equal, right, then our function table just shows the same age for each of them. This would be like if they were twins, right? Same age. They're always going to be the same age. It's equal. Okay, well this one is what happens if the sister is a year older than the brother. So you're going to take B plus 1 gets you S. So 1, 2, 3, 4, 5, and 6. Okay, well what if the sister is 2 years older? Well, 2, right, 3, sorry, very sloppy, 3, 4, 5, 6 here, and 7 here. Okay, so notice each of those are increments of 2. If they were 3 years older, they would always be that 3, 4, 5, 6, 7, oops, sorry about that messy 7, and 8. Okay, 4 years older, 4, 5, 6, 7, 8, and 9. Okay, so got your function tables filled in. So now you're going to graph the ordered pairs and connect them up. Okay, so this first one, again, if you looked at its ordered pairs, you would see 0, 0. They're always going to be the same. It's incrementing up by 1 each time. So I'm going to start at 0, 0, and I'm going to increment up 1 each time. And I could carry this all the way out as far as the graph would let me go, right? And that's representative, that black line is representative of if they were the same age each time, okay? It looks like I need to do a little adjusting here because it should be 10, 10. There we go. Okay, so think about each of your ordered pairs. They should fall onto that particular line at each increment. And I'm off just a smidgen here as well. Okay. Just being very careful that those all stay the same. Then if we look at this next one, 0, 1, right, 1, 2, and so on. When I look at plotting those, I can do the same kind of thing, okay? So 0, 1, oops, sorry about that. Let me delete that little line off of there. Okay, 0, 1. Hello, undo, get a line again. Sorry about that, guys. 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, and so on. This line is going to run parallel to that other line. Okay? All right. On the next one, same thing. It's going to run parallel to it. If they were 2 years apart, we'd have 0, 2, right, and running parallel perfectly to these other lines. Okay, if you graphed out the next one, again, same thing. It's going to run parallel to it. Okay, because they're actually increasing in age by each incremental year. So the growth is going to be the same. Okay, so what could we say about this? I know I didn't graph that last one, but you guys can if you want. So if we were needing just 2 ordered pairs to do this, we would need 0, 0, especially if they were 10 years apart. So if you and your sibling were 10 years apart, we would need 0, 0. Oh, it's not 0, 0. It would be 0, 10, right? 0, 10, because 10 years apart. And then we would need another point. It could be like 5, 15. That wouldn't work on this particular graph necessarily. Oh yeah, that would work perfectly on this graph, 5, 15. Okay, so describe the relationship you see. You should say something about the increments being equivalent, equal, each going up as a stair step. Okay, so complete the function tables and then write words for them. If x and y are equal, right, all you have to do is run through, write the same numbers that you see in x for y. My 3s are turning out terrible today. Sorry about that, guys. Okay. If x is equal to times 2, right, you're going to multiply by 2. So it's like counting by 2s. Okay. If x is equal to plus 2, right, then just add 2 to your x. Okay. Okay, so you guys should have those filled in. So a rule in words for these, let me pick a smaller type. X is equal to y, okay? A rule in words for this next one is y is equal to 2 times x. And a rule in words for the next one is y is equal to x plus 2. Okay, so it's just saying out what it is. Okay, now you're going to plot them and connect each one. Okay, remember when they're equal, increments go up evenly. So 0, 0, 1, 1, 1, 2, 2, 3, so on, all the way up. Okay, and again, you could extend that out farther. When it's multiply by 2, so x is 0, 0, multiply by 2, it's still 0, 0. 1 times 2 is 2, so just kind of connecting up. It's 4. Okay, just watch each of your points and make sure you're increasing by the proper increment. Okay, and then the last one is adding 2. So if you were to add 2, okay, so it would be 0, 2 right off the bat, right? And then 1, 4. Right, so think about adding increments and how that changes things. Okay, So you can extend those lines out. I want you to talk about how the lines are alike, how they're different, and what adding does versus what multiplying does. And then this is what you're going to come back and share with your